Okay, everyone. So in this video, we're going to be looking at finding the gradient of the tangent to a curve. And if we have a look at the graph here, we've got the curve y equals x squared, okay? And we're going to find the gradient of the tangent to this curve at the point 1, 1, okay? So let's have a look at the point that we're after. It's just here, okay? So it's 1, 1. And we can visualize what the tangent's going to look like. Let's bring the tangent across like this. And the tangent is a line that is sort of runs across a curve like that. And it touches at exactly one point on the curve. Okay. It's a little bit hard to imagine and hard to visualize like this. But you can just try to imagine that there's one point in common between this line, this tangent that I just drew, and the actual curve itself. Okay. So that's what a tangent is. It's the line that goes through that is that just that one point. So to find the gradient of this tangent, or another way of thinking about it is to find the slope of this tangent, is to find the derivative. Okay, so we've got y equals x squared. So we're going to differentiate this curve, and this will help us to find the gradient. Okay, so y equals x squared. So we first of all find the derivative, and that's just going to be 2x. Okay, so our derivative is 2x. What we now do is we substitute the x value of the point that we're after into that derivative. Okay, and I'll show you how that works. So when x equals 1, okay, so that's the x coordinate that we're interested in. When x equals 1, y prime, or the derivative, is going to equal 2. Okay, so I've just put x equals 1 there, and that's just going to be 2. 2 times 1 is 2. So that tells me that the gradient at this point of the curve is 2. Okay. And another way of visualizing it is if you have a look at the slope of this line. Another way of measuring the slope or calculating the slope is to find the rise and divide that by the run. Okay, and I'll show you what that means. So you can have a look at this. If we go across like that, okay, so we've gone across one there. So that's the run. Okay, that's run across one. And then if we go up, that's the rise, okay? And we've gone up about 2 there. So yeah, you can see it's a little bit off, but yeah, you can see what's going on there. So if we do that calculation, so it's the rise, which is 2, over the run, which is 1, it's going to be this, and that's just equal to 2, okay? And that's exactly what we found over here with our derivative, okay? And the derivative is useful here because obviously there's going to be situations in the future where you can't do something like what I've just done here with the rise over the run. So you're going to have to use the derivative to calculate the gradient of the tangent, okay? Okay, so let's have a look at another example. So this one's just a little bit harder, but we can follow exactly the same process and we should be able to find the gradient of the tangent that we're after. So let's have a look. First of all, the curve is x squared plus 12x plus 20, and the point we're after is negative 8, negative 12. Okay, so I'll just point out where that point is. So it's around about, looks like it's going to be about around about there. Okay, that looks about right. And let's try and visualize the tangent now. I'll just pull that across. And it looks something like that. Okay. So yeah, that's a little bit inaccurate, but you can see what I'm getting at there. So we're trying to find the gradient of this tangent. Okay. So let's find the derivative. So it's going to be something like this. Okay. So we've got x squared plus 12x plus 20. So it's going to be 2x plus 12, and that's it. Okay, so that's our derivative. Now we're going to substitute the x value in. So we're interested in this point, so minus 8 minus 12. So when x equals minus 8, okay, our derivative is equal to minus 16 plus 12. So I'm running out of room a little bit there. So minus 16 plus 12, which is going to be minus 4. Okay, so that tells me that the slope or the gradient of this tangent, of this line here, is minus 4. Okay, and that's it. Okay, so really simple, using calculus, using the derivative to find the gradient of the tangent.